Hello guys, I hope the lab went well this week. Unfortunately I have, or I guess fortunately for me, I have another interview this week out in California at UCLA, so I won't be there. However, you guys should have gotten a peer of mine there to help you out for today. Uh, so unfortunately all these grad schools try to fly you out, around Thursday. Or even earlier. I'm leaving Wednesday this week, so it makes doing this class a little tough. But you guys are good students, and I know that you can handle this, and I think I've been providing sufficient feedback for you to continue making some learning progressions here. So this week's lab is going to be a lot longer and a little bit more complex than the last two. I have put together a informal demo of some of the principles, which will be uploaded to my courses, or hosted on YouTube, or both. Probably YouTube. I'll let you know. Because this lab is our first real jump in difficulty, I strongly encourage that you start working on the lab a little earlier. You can submit often. It's not a hard one for me to check to see if you did it right or not. And then use the discussion board in a more appropriate way than we've been using it for the last couple of weeks. Mostly because we have more to do. So yes, I'll start just briefly talking about some lab principles. Again, there's going to be a video online, but first thing you'll notice is that this lab requires two separate scripts to be submitted. You'll be using the source function in one of the scripts to call a function that you'll define called getRanDF that you define in the other script. So one script simply has a function definition, function declaration and definition, and in your other script you're going to use it, but that's not the main purpose of that script. Let's see. If you're inexperienced with programming, you can think about it as just kind of copying and pasting the script into the other one you're sourcing it into. Usually people do this for a couple of reasons. One is kind of just organizational. It kind of makes the code look nice. The other one is to factor out common code so that you don't have to rewrite the same code over and over again. And then yet another reason would be extensibility and modularity. If you end up breaking your code up into smaller, self-contained pieces, it makes it easier for you or other people to reuse or build off your current code. All right, makes sense? All right. The next big thing we are working with are some new data types. I understand that you guys probably touched on this just a little bit in lecture, maybe for homework 1, but we're going to be working with a couple new data types. First are matrices. These function very much like the mathematical matrices used in algebra way back when, or if you're more advanced in math, kind of linear algebra, right? They have at least 2 dimensions and form a grid of numbers. And the matrix data type can really only hold numbers, though that's not necessarily true. If you look at the demo, you'll see that you can change things, but everything has to be monotyped at the very least. It makes most sense to have matrices. But matrices aren't really what we're focused on. We want to use a more flexible data structure than matrices. Instead, we're just kind of using matrices as an intermediate to R's biggest and baddest data structure. They're called data frames. Right? So data frames are used all over the place. They can pretty much hold any kind of data and are more abstract in their meaning. This versatility does come at a cost, and you might encounter this when you work with it. It's harder to make assumptions about the data in your data frame, and as such, until you guys get more experienced with it, in this week's lab, you're going to make a matrix first, so you know that everything's the same data type, and then convert it into a data frame, which allows us to make some assumptions about the data, at least initially, while still providing the versatility that data frames allow for. Just like matrices, data frames have at least 2 dimensions. You can make like a single. It'd still be like 4 by 1. So usually only 2 dimensions, but you can get fancy. You could have a data frames populated by lists that kind of expand it into a third dimension, but not important for this week. One way to imagine it is kind of like like a more powerful Excel spreadsheet. Many people who use R say that a lot of times the end game is just to get your data into a data frame that makes sense, to organize and convert everything over. After that, R can pretty much take care of whatever analysis you need. You'll learn how to kind of iterate through each element individually, and as well as entire columns as a whole in this slide. The next thing we're going to talk a little bit about random numbers and random seeds. Random numbers are pretty useful in a lot of programs, especially simulations or things of that nature. Sometimes you need to break a tie, sometimes you just need a random element to your program. While the most basic random functions in R are not truly random, they serve as a close approximation, and you'll likely see it used in people's programs. However, because this process is not truly random, it does allow us to use something called a random seed, which will cause the same random numbers to be generated every time that you execute the program. There's a lot of CS and physics around the generation of random numbers, but this is really all you really need to know for this week's lab. Alright, so many of you are probably familiar with looping constructs from other languages. R has them too, but for those of you not, R will allow you to perform a series of instructions over and over and over again until some condition is met. The two main kinds of loop that people use in R, at least, are while loops and for loops. While loops will check the condition after every iteration and evaluate if the condition has been met. If the break case has not been met, then the loop will continue running. While loops are, I would say, probably most often created during while loops. Infinite loops most often happen in while loops which the break condition is impossible or very, very tough to meet. So yeah, that's what an infinite loop is. If you didn't know, let's see, what else? For loops. For loops are a little bit different. They iterate through a data structure a set number of times. For instance, iterating through every element in a numeric vector of length 5 could be done 2 easy ways in R. The first, for every element in the vector, or the subset, the desired subset of the vector, do something. The latter deals with the position. We kind of call them indices, and it's actually how I most often use loops, for loops. And it would be said more like, for every position or index between 1 and the length of the vector, or the desired subset of the vector, do a thing. It's a bit more cumbersome syntax, but I find it to be more versatile. So now I have access not only to the element themselves, but what position in the vector or data frame or matrix that data is. If you were confused, I did include examples of this both in the demo. Otherwise, I do suggest looking up syntax or asking some people how to do it. All right. So the last principle I'm going to talk to you about before I kind of step through the lab with you is benchmarking. So in this lab, you're going to compare the 2 times of 2 algorithms that you write. Since R is a bulkier language than something like C, and since we tend to, as bioinformatics people, work with larger data sets, even small differences in efficiency can sometimes have a large impact on the overall runtime, especially if the functions run enough times. So in this lab, we're going to use a rudimentary benchmarking function to compare the times of algorithms that do the same thing in different ways. So if you were doing this in practice, then you would obviously pick the faster one you're trying to achieve analysis in a reasonable runtime. All right. So I'm just going to walk through the lab real quick for you guys, and then we'll see if there are some things I can elaborate on or elucidate for you all. The first task you have is to write a function called getRandDF. And that basically uses a matrix to create a data frame of random numbers in a very specific way. Each position's value will be determined in the following way. First, you're going to generate two random numbers between 0 and 100 inclusive. Then, now that you have these two numbers, you're going to generate a random number between those two numbers, which is also inclusive. More specific details are available in the lab, but that's the gist. This function will be stored in a separate script and be used in the script containing the second task. All right. I do provide information in the relevant information section of this lab about how to source files into each other. The second task is to write a script that reads in a specific data set, which is available on my courses. Read it into a data frame in a specific way. Unlike lecture homework 1, you may not use read CSV. You must use read.table, which is the generic case for read CSV. And then you will reformat the data frame to make it easier to use. And then using the plotting skills you practiced during week 2 lab, you're going to plot some specific columns, save it to a file. But it's not over yet, right? We still got to get to the benchmarking and stuff. Then you're going to define a function that has two modes, slow and not slow. And I give you pretty verbose instructions on the steps of the algorithm lab, so I won't really elaborate here. But the idea is that they'll be doing the same, the end result of each mode will be the same, but one of them will be much slower than the other. But after you define the function for both nodes, you'll run each node, once you define the function for each mode, you will run each mode and compare the times using benchmarking, which I elaborate a little bit in the relevant information if you don't know how to do. You use the proc.time function. If you have any questions about any of the steps of either of the modes, just let me know or post about on the discussion forums. And don't forget to submit both of your scripts as well as your README as zip files. Alright, so I need both scripts, your README, and you should zip it. Alright, overall this lab can either be fairly easy or a fairly challenging lab, depending on your experience level. The more closely you follow the steps of the lab, and the more strictly you adhere to the order that I presented it in, the more likely you are to get the desired result. I kind of wrote it in an algorithmic fashion, even kind of indenting where these natural indents will occur, that is, while loops, for loops, if statements, things of that nature. What else? It's more likely, you're more likely to desired result if you follow the order. And like I promised, I will post code for Lab 2 here in sometime this weekend. I'll let you know when it's up. I'm sure I send enough emails and notices to you guys that you might space it, but either way, post it. And I will be offering a plethora of office hours to compensate for my absence. Keep an eye out for the demo. I've already created it, and I think it's about an hour's worth of material. Again, it's all live coding, so it's not super dense material. There are times where it takes me a second to figure out. I did record the demo on the train ride back from Yale, so sometimes I simply stopped typing because the train was really shaky. So don't lose patience or think the video froze if it stalls for a second or two, because sometimes I was just shaking around so much I couldn't do anything. All right. So yeah, keep an eye out for the demo. Wish me luck, and don't hesitate to ask me questions, email me, or come to an office hour. Make sure you do your discussion posts. You will have an extended deadline for this I'm thinking I'm going to give you probably a day longer than last time. Probably till that Monday. But check the due date on the Lab3 when I repost it here this week. Currently, it doesn't have a date on it because I technically haven't assigned it yet. So when I assign it Friday, it will have a date. But it is already available if I end up posting this video early. I'll stop rambling now. Have a good weekend. Bye.